forgot to talk about my game. Hey.
Yeah.
Hopefully, I'll just show her the video later. Okay, so hello everyone. My name is Claudiu Moise. You guys can call me Claude. I am a junior here at Northeastern, and this presentation to you today is brought to you by the Computer Science Society. I am doing this sort of as a presentation for my CS 307 class, which touches on programming languages in general. So it's sort of like you take up programming languages and try and break it down to its like components and try and sort of like explain to somebody else what it is all about. And so part of that is creating this presentation and presenting it to you guys. So as you may have heard, Python is a very popular programming language, and it's one of the big things happening in the industry. So this presentation is going to be sort of like an overview. It's not going to teach you how to program in Python from start to finish, but it will give you the general knowledge to attack it in the future. And so when somebody mentions it at work, you'll sort of have an idea of what the strengths are, what it's generally used for, things of that nature. But if you are interested in learning about Python, I'm going to plug my friend Brandon, who is the leader of the Python workshop here on campus. So if you have any interest in that, you should talk to him. So I've got a lot to cover, so let's dive right into it. So this is sort of what I think about when I'm looking at Python compared to other traditional programming languages. So I put the rabbit under Python for productivity because Python is a very productive language, but it's not a very efficient one. And what I mean by productivity versus efficiency, efficiency is how the language uses the machine's natural resources. So think about things like CPU memory or CPU cycles. CPU memory is not a thing. And generally what that translates to is how fast your program will run eventually. So a very efficient program will run very quickly, whereas a less efficient one will slow down and probably take up a lot more memory than it needs to. So now we're going to look into the characteristics of the language. So Python is a high-level language, similar to Java. And for anybody who hasn't heard of what a high-level language is, the lower level a language is, the more you have to work with the machine implementation details. So for instance, things like where do variables get stored in memory, or binding your methods in memory. But with a high-level language, it sort of abstracts all of these hard-to-understand concepts for beginners, because unless you get into something like systems programming, it's very rarely relevant to you. Second of all, Python is a general-purpose programming language, and what that means is that it can be used for almost anything. So it has basically any application you could think of, from doing things on the web to doing software development. Also, it is considered, when you will hear about Python, you're probably going to hear it in the context of a scripting language. I personally think that that's a little bit of a misnomer, because scripting is one of Python's applications. But certain languages, like Perl, are strictly scripting languages. And we'll get, when we talk about like the real-world applications of Python, I'm going to elaborate more on what scripting means. I skipped over Python's other feature. Is that it's a multi-paradigm language. Anybody have any idea what that means? Okay, a programming paradigm is a system of ideas and techniques for solving problems. For instance, everyone's heard that Java is an object-oriented programming language, correct? That's its paradigm. However, there are programming languages such as Lisp, which are considered functional programming languages, and original C is considered a procedural programming language. Now, I don't have time to go into exactly what the differences are for each one, but the important thing to realize is that Python is not a pure language, and that's actually towards its benefit, because a lot of programming languages start to get very weird because they need to keep their purity of the paradigm. So something which will be very obvious to solve in one paradigm versus another. So Python sort of puts practicality before purity. Python is an interpreted language. Now, everybody knows what a compiler is? When you first run your Java, you first have to compile the program before you can run it. However, the difference is that Python does not use a compiler. It uses an interpreter. And what that generally means is that your program will be read from the first line and will be executed all the way to the bottom. Whereas with a compiled language, it has to sort of like figure out where its variables are going to live in memory. It's got to bind the names of the methods everywhere, which takes a lot of time. And but with Python, you can easily just write a command and run it. And that's sort of one of the things that makes Python a fast programming language in terms of productivity. Last of all, a lot of things in Python are done on the fly. So things like your variables, like where they're stored and stuff like that, is all done on the fly. And we'll talk a bit more later about that concept as well. Now we're going to show you a little bit about the history of Python. I have a look at my notes. So it was created by this Dutch guy. His name is Guido van Rossum. He created Python. He started working on it in 1980, which, a lot of people say that Python is a very new language. When you think about when it's been developed, it's kind of still, it's been about around as long as a language like Java. But it's only recently gathered popularity when it reached version 1.5. So currently he's working at Dropbox, which is an all Python service. Currently Python also has this organization behind it called the Python Foundation, of which Guido van Rossum is the current president of. So before we start talking about the evolution of Python as a programming language, because it's sort of a dry subject, I thought we should start with a little bit of fun facts. So when I show you more of like how the code looks like, you'll understand what I mean by the Python code looks very similar to pseudocode. The name actually comes from Monty Python's Flying Circus. Has anyone ever seen a Monty Python movie?
Yes.
Yeah. I thought that was kind of funny. And actually, the whole programming language of Python started out as a hobby project to keep him busy over the winter break when there's Christmas and everything's closed. So, talk about education. Also, he holds within the Python community, this guy holds the title of Benevolent Dictator for Life. And sort of like it's a tongue-in-cheek way of saying that any sort of Python programming decision that impacts the language has to be approved by him. And the only other person to hold this title is a man named Linus Torvald, who was the inventor of the Linux operating system. So benevolent dictator right here. So now we'll talk about the evolution of Python. So don't be scared of the diagram, but just pay attention to the red line here, because we're down here. This is where Python was created in 2000 and the latest version of Python, 2008. And up there is the first programming language ever invented, which was Fortran. And so you can see on the left-hand side over there, the year in which each of these programming languages was created. So you can see we go from Fortran, Algol, down to C, then to C++, and into Python. And then we also take stuff from Pascal and Modular. So everything on this diagram are languages which Python has either directly borrowed its concepts from, or it's taken certain design decisions from that language. And we're going to go through a couple of these, but we're not going to go through slow because there's a lot. So I'm just going to cover sort of the basics. So Fortran is kind of the granddaddy of all programming languages. And it's really just one step above machine code. It was originally built by IBM for use in scientific applications, because that was sort of the only thing that computers were used for back then. Now we, have uses for everything. And it's still one of the most efficient languages out there today, but you probably will never actually have to use it. But this is sort of where all programming languages came from, and Python actually also has one data type coming all the way back from Fortran, which is called the complex data type, which, did you guys remember real and imaginary numbers? That's the kind of data type that the complex data type stores. We'll talk more about data types when we talk about language structure. But immediately after Fortran came a language called Algol. And it was sort of an international effort that came to sort of standardize programming languages, because there was this fear of programming languages becoming machine dependent. So like you would have to have a specific programming languages for certain computers based on their processor, and imagine the nightmare that would be for everyone if that's how you had to learn programming, not just differences in Mac versus Windows, but like the actual processor. So it made a lot of great technical strides. However, the reason why you don't hear a lot about it is because it didn't catch on in the commercial sphere, because Fortran had already kind of gotten a death grip on everything computer related. But it did influence a lot of its successes going on. The idea of user-created data types came up, and it was a very technical achievement. Now we're talking about C and C++. Well, and these you might have actually heard of. They're still in wide use today. They're one of the most efficient languages still out there. So it'll make very good use of your memory and things like that. However, it is also extremely, extremely unforgiving to users. Like the comic up there is talking about pointers, which you'll never have to deal with in Java, hopefully. But in C and C++, if you refer to the variable in the wrong way, you'll end up getting garbage data. So, and for me, when I was playing around with it, it wasn't even clear why that was. But it was created as the replacement for Fortran. It's used mainly for systems programming. So like making operating systems and system daemons. Now, we're talking about Pascal and Modular, and these are a little bit more obscure, I'll admit, but Pascal is an important language because a lot of people who started learning programming actually started with Pascal. It was actually the mainstay in teaching people programming up till the 90s. The nice thing about Pascal was it was very user friendly. When you made a big error like that caused your compiler to crash or whatever, you would get these very nice diagnostic messages that would tell you exactly where you messed up and what you needed to do to fix it, which is why it caught on and why people, even though Pascal was never intended as a language to build actual programs in, people felt so comfortable with Pascal that they wanted to keep using it even after they had, learned the language and were supposed to graduate to real programming languages. And Python took this lesson to heart and made itself as easy to learn as possible. And you'll see when I show you the syntax. And modula, this is one of the ideas that Python took, was the idea of modularity, having a very extensible programming language. So you have your standard library, and when you go to import something, how you write the import statement. Python is of the belief that you have to have as much included in that standard library for you to pull as possible. Whereas other languages, they're a little bit more monolithic. Now, ABC, this was not on the timeline, but it's a very important programming language. And that's because it's the immediate precursor to Python. You see, the creator, Github was a junior developer on this programming language, which, according to him, it taught him everything he knew about programming. And it was created at this Dutch university called CWI. And it had a very clear, simple, and elegant style. All of the keywords and stuff were in plain to understand English. There weren't a lot of things like system.out.println and very obscure programmatic terms. It really tried to be another teaching language like Pascal. And this was one of the lessons that Python, that Github took as he was developing Python. Unfortunately, the language isn't really supported anymore. It was abandoned after only 5 years after it was created, and that was chiefly because people in the mainstream didn't really see the use for it. So then the project shut down, and we started to work on Python. Now, the birth of Python actually came from a very practical need. Github was working at a multimedia student group at CWI called Amoeba, where he had to work a lot with Bash and Unix scripts and C programming scripts, which of course were like the mainstays of the day. Now, the problems that we ran into while he was developing was that when he started to use C to develop any programming language, any programming application, he found that he started to get bogged down in details very quickly. Things like where things get stored in memory, all that stuff. And when he tried to create those same programs in Unix or shell scripting, he found that it didn't have the data structures that you would want, that you had access to in C. So things like having structs, if anybody knows what that is, arrays and things of that nature. Those things weren't really easily provided in Bash. So the practical application of Python, he started to work on this language, which should allow him to create a connection to bridge the gap between shell scripting and C, which was very powerful thing, and that's where you'll hear that Python is a glue language from. So it's this idea of being able to connect different applications written in different programming languages, and we'll talk about more in the application section. So of course, Guido Barosum started to work on ABC. He saw a lot of its flaws, and he said to himself, I think I can make a better programming language. So he worked to address a lot of the pitfalls that were present at the time. You see at the last bullet point I had, extremely extensible written down. That was one of the key downfalls of ABC. It had what we call a monolithic programming language structure, which is essentially saying that it's very hard to write an extended library. So how I was talking about modular earlier, you can easily like write a new library, plug it in, use its methods, use its whatever, and get up and running fast. But the designers of that programming language, the ABC programming language, thought that beginner users would not have to go out of the program in order to write applications. So they didn't include any extensibility features. Python, on the other hand, saw that this was the main reason why ABC sort of collapsed. This lack of like senior programmers being able to go in and extend and use other people's libraries. So Python is extremely easy to extend, which also helps with the fact that it's a glue language, because you can include libraries which will help you talk with Java programs, which will help you talk with programs written in C. So it's very flexible. Now we have this idea that Python isn't a perfect language. It was never even intended to be people's first programming language. It was mainly intended for people in this sort of situation of having to glue languages together and having to communicate between various appliances. And but what people found was as they were writing their prototypes in Python, and as they were creating these mock-ups, they found that the mock-ups ran almost just as well as the actual programs that they wanted to write. So they said, why bother? They're like, well, I have this program which I wrote pretty easily, it works okay, it's good enough. And that was the sort of the initial design of Python is, everything's good enough. And you'll find that while Python doesn't have the performance or the efficiency of other languages, you can get started very quickly. You can get your ideas rolling very quickly. You can learn the Python language very easily, and then create a prototype even easier. So this idea of, because Python is, you'll see when I show you the code, it's a very simple and beautiful language. And that often beats out performance. Why? Because it leads to increased readability. It's easier to read the code, it's easier to understand what it means, what it's supposed to do, which, makes things very comfortable for the programmer, and that's one of the key design philosophies of Python. They don't want to make you work for the machine, they want to make the machine work for you. And isn't that the whole reason why we're doing programming anyway? So now we're going to talk about one more thing before we show you some code, and that is the Zen of Python. It was created by this guy named Dean Peters. He wrote this sort of 20 principles of like why Python, like what is behind Python. Sort of like it's 20 commandments, if you would. Now, these aren't rules or anything, but it sort of really gets you into the mindset of what these designers were thinking. So I didn't go through all 20 of them, because we'll be here all day, but I did choose a couple. So beautiful is better than ugly. And the reason is It makes, when you don't have to struggle to read the programming language, it becomes easier to write programs. It becomes easier to share code between people. It becomes easier to maintain a large code base because you don't have to struggle to understand what the person was doing. Now, explicit versus implicit. Explicit is better than implicit. Why is that? And that's because, have you ever had to write a piece of code and then you couldn't figure out why it was doing something, and then you found out that something was being called that you had no idea was being called? And that's because it was sort of like this implicit calling. I remember constructors, the idea of explicit and implicit constructors, if that jogs your memory. So it's better to have explicit because you'll spend less time just hunting for bugs. Simple is better than complex. Well, that seems like it should be very easy to understand, but some programmers like to write everything in one line of code, and which that, it's very clever. It's very nice that you're able to do that, but when somebody tries to go and read it, they're like, what is this? What's this random semicolon doing in here? What's a ternary operator? And so, none of that. Python would rather that you don't complicate yourself for the sake of making yourself look smart. Readability counts again. It's easier for everybody involved in the process. Practicality beats purity. We said earlier about how Python is a multi-paradigm language, how it allows the programming language to use things from functional programming, to use things from the object-oriented paradigm, and because it's able to use things from every paradigm, it's easier to bridge the gap for every sort of language involved. And this last thing, we're going to get into a tiny bit of history. There's this language called Perl, and it is used for server communication and for web development. And its motto was, there's more than one way to do it. Does that sound like a nice idea for everyone? Don't we want some variety in our lives? But that's actually a terrible idea. And that's because, think of if you're trying to debug somebody's code, and you're able to write your loop statements in any number of ways that you want, or write your if statements in any number of ways you want, you'll be debugging until the end of time, because somebody decided he liked one method better than the other. So in Python, the idea is there should be one obvious way to do it. And while that might make life boring for somebody, it will also mean that you don't have to try and compare different solutions and things of that nature. So you'll get to one solution and one solution only. And here we go. We can finally start to look at some code. So on the left-hand side, I've got our Python code. And on the right-hand side, I have our Java code. Because I'm assuming that everyone here is more familiar with Java. So we're gonna start with our classic Hello World application. So you can see we've got this very simplified syntax in Python. All you have to do let me make this bigger. All we have to do is simply write print hello world, and that's all you need to do. There's no system.out.println, there's no public static void main, we don't have to worry anything about classes. And then we're going to make the same program. We're going to take input from the user, and then we're going to echo things back to them. Now you can see here, did I declare my variable anywhere? No. It's not initialized. In Java, this would be terrible. I wouldn't be able to run this program. But that's the nice thing about Python. We have something called dynamic typing and dynamic memory allocation, which allows us to create variables on the fly and to easily replace them. And does anybody notice anything else on there? No semicolon. Very good. Anything else?
You don't need to build a scanner to read an input.
It's very good. Because, when I started programming, I had no idea why that was a very arcane concept to me. I didn't understand why I needed to make a scanner object. This is crazy. But here, the program is just able to read it. Does anyone notice that I didn't have to tell it that it was a string? That's another thing. Python has implicit typecasting. So based on the inputs that you give it, the system will be able to tell what sort of variable you mean to use. Whereas in Java, you have to tell it it's a string, and if you don't give it a string, it gets very mad at you, and it crashes on you. With Python, if I wanted to later overwrite that same greet variable with a number, I'd be able to do that. And the compiler wouldn't give me, or the program wouldn't give me any errors. And I would just be able to keep on trucking. So we see that for a beginner starting out in Java, there's a whole lot of things that you have to ignore in order to even start doing anything. What is public static void main? What is a class? What are these weird squiggly lines doing everywhere? But with Python, there's no such thing as block structure. There's no semicolons for you to get confused over. And I lied. There is block structure in Python, but you never have to worry about losing a semicolon or a curly parentheses ever again. How many hours have we spent looking for semicolons and curly parentheses? Far too long. So this is our hello world. We're gonna ratchet things up again. We're gonna go straight into structure basics, right? So let's see. I think I'm gonna focus in on the Python again. So we talked already about our dynamic typing, our implicit typing. You'll see that I'm a bad Python programmer. It's true. I actually declared my variables up there, but it's not necessary. It really just adds 7 lines of code when I don't need it. But what can you say? I'm a creature of habits, and you see I even included a semicolon there, even though I didn't need to. So this program is sort of a test of like what a real programming application in Python would look like. So say that I was giving the requirement to take students, take their name, take their GPA from high school, and take their GPA from college, and put it all together and create an average. This is what this program is supposed to do. So we see that we still have, I asked the user what's their name, what's the college GPA, the high school GPA. I asked them if their GPA is weighted or not. You can see that we still have the convenience of doing casting if we find a function which has need for a specific data type. And that function that you see over there, .strip, that's used in case the user enters something with a space or with an enter, and because further down I do an if statement, and you see I'm checking if the user inputted a y or an n, which stands for yes or no. and that's going to tell him, hey, this student's GPA is weighted or it's unweighted. So that's an example of how we do if statements, and you know, can we see that I put this indentation over here? In this situation, your indentation actually is mandatory. So that's kind of weird. That was kind of weird for me to grasp. So everything that's tabbed into that if statement is part of that. It's essentially the same thing as if in Java I did like two accolades, right? Is that squirrely parentheses? That's exactly the same thing. So doesn't that look a lot better too? Just to have the tab in and to have all of your code down there. So we kind of can, I hope that you get a feeling for why this programming language is a lot more readable. Let's see, what's else important? We talked about dynamic typing. So we're about to, if I'm not mistaken, so here we can see that the Java program keeps going and keeps going. And in the Python example, I wanted to show you this first because in the Java example, I actually had to write the method from scratch because I wanted to be able to round to a certain number of decimal places, but that feature wasn't available to me in Java, so I had to go and look for a way to do it. But in Python, that's with the idea of extensibility, that's actually one of the things which is built in. You'll see over here, I've got the round function over there, and then I'm specifying right here to round it to do decimal places. So I'm trying to make the time here, but so you'll excuse me if I'm going a little bit fast. Now we're going to get into a little bit more advanced. We're going to talk about arrays, functions, loops. And for my program, my GPA program, let's say I add some additional requirements, and I say, I'm not going to be sure if this person applying to my thing is actually a freshman or a non-freshman, somebody who saw more, and so if it's a freshman student, I want to look at both their high school GPA and their college GPA and round that. But if they're not, then I want to do something else. So, and also I have this additional requirement, I need to give them some sort of score. And that's what this array is here for. So based on if their GPA is a 3.94, they're going to get a certain grade. And if the GPA is something else, then they're going to get a, because it's sort of like a point system. So you'll see this is the difference in how you declare something in Python versus in Java. Whoa. And here in Java, you have to declare the data type and things of that nature. Okay. So in Python, your arrays are actually called lists, and there's a little bit more technicality in that, but we're not gonna worry about that too much. And then we're gonna declare our first function in Python. Are you ready? So I'm skipping through this because this is basically what we've done before in the previous program. But here we have our first function, and this is what it looks like. We have the keyword def, censor defined, and then we have, see, this more clearly displays what I mean to you with the block structure in Python. So you see here I have this indentation, and everything below that indentation, that's part of my function. That's what's going to get called. Same thing as if I had these bracket structure. And we can see that I can pass in my parameters. I use the 2 dots to define the function, and then within that we have another indentation for the if statement. And you can see it's very neat, it's very ordered, very readable. Like, do you have problems reading that as you're going along? So one thing that is kind of weird about Python, I'll admit, is the way that because this is a interpreted language and it's read from top to bottom, if I have this line, this function call for calculate rounded GPA, if I have that above my definition, the compiler is going to give me an error. And the reason, or it's not a compiler, it's an interpreter. The reason for that is because it went from top to bottom to read my whole program. It didn't find any definition of the function, so it thinks I've made an error, and that's when it's going to say, that's when it's going to crash. So in Python, you normally would put your function definitions at the beginning of the program, whereas I know in Java, it's usually standard to put them at the end. And that's just because Java has the luxury of being a compiled language, so before even your program runs at all, it already knows what methods it's going to call. Whereas Python has no idea what you're going to do until you actually do it. And the last thing we're going to talk about in terms of code is doing loops. So you can see it's think of it as the for each loop in Java. So the way that it works is you start with the 15th index, and then you go all the way to the 30th. You stop one before your actual last element, and then you go through each one. And we're looking in the array to compare it to what the user inputted versus what our criteria is. And the actual index of the array is the point values that we're going to give our candidate. So it doesn't look too different from our if statement in Java. Maybe it's a little bit unfamiliar, but just so we have a little refresher, that's what it looks like. And I think that's enough talking about code. We're going to spend the last few minutes talking about real-world applications, because I'm sure everyone wants to hear about that. So, because as you've seen already, Python is very easy to approach. You don't have to worry about these these hard to understand technical terms like variables, data types. You can really get into writing very simple coding applications, which makes it a great teaching tool. And it also makes it, for people who aren't computer scientists, it gives them the ability to also use Python and use the power that a computer can give them. So as you saw, because the syntax doesn't have these very complicated things attached to it, you can get up and running very quickly. Now the other use of Python was as a prototyping language. And for the reason why you would do this is, say you were working with C, and you can have the benefits of having a very productive language and a very efficient one by first writing your program in Python, knowing what generally sort of like what the structure you need to follow, and then just translating it into C, which will then give you the efficiency to do things. But as we mentioned earlier, your prototype can be so good, you don't even end up need to going through the hassle of remaking it in a more efficient language. Now, I skipped over the use of scripting and automation to give you a very, very easy to grasp concept. Has anybody ever had to organize their photo album, and they've had to go in there and go in one after the other and write the name of each photo or something, or like rename your folders, things like that? Anything that has to do with your file system, you could actually write a Python script to rename all those files for you, and give it like a set formula of how to do it, and then it'll do it for you, like through the Windows terminal and all that. So there's a great book called Automate the Boring Stuff in Python, and I highly recommend it because it'll shave off a lot of tedious work. And you can also use it with things like Excel spreadsheets, and I'm sure that other people have come up with much wackier ideas. Now, Python is also a glue language, as I mentioned earlier. That makes it easier for you to use it in any project. Say you began working in C++ and you found a very old module that was written in an outdated programming language, but you found it easy to use. You would then write a Python program to create a way of translating the output of one program into another, and that would help you out in terms of translation. And that's why Python is a popular language, is that it allows this sort of connection between services. Now we have web scraping. So, for instance, say I had a website where I sell products online, and I want to see what my competitors are selling and for what prices. I could write a Python program which looks at my adversary's website, checks what items I'm selling, what items they're selling, and what prices we have them both listed at, and give me an outputted format and make it look nice. So if you want to generally exploit the web in some way, you would write a Python web scraper to do that. And so with the final two uses of Python are in creating dynamic websites. You see I have up there listed Django and Flask. Both of these are used in web development. If you want to create a website which updates on the fly, or dynamically generates content without user, or interact with the user in some way, you could use Python as the back-end portion of your website, and you can use it in the same way that you would use PHP or Perl to write some HTML code on your site and display that. So with that, we reach the end of the presentation. I'm hoping that you understand better this analogy that I drew up for you at the beginning. Because I would highly suggest everybody try and learn Python. It's definitely one of the languages that is going to dominate in the future, just because it is so easy to learn and it has such a wide range of applications. Thank you. If anybody has any questions, feel free. I can stick around until 4:15. Let me turn on the lights.
Claude, who would they contact to join the CSS Society?
So if you are interested in the Computer Science Society, I am an officer, and Brandon is as well. So you can, if you're interested in getting involved in the club in any way, come see me, and I'll write your name and email them.
What does the club do?
We have all sorts of events. This talk was sponsored by the Computer Science Society, and we're hoping to have a lot more events soon. The job fair that is coming up, that will be that will also be sponsored